Yes. On Friday, we were working with breaking down radicals, and I did the majority of the section. The last thing that we have to talk about is rationalizing the denominator. You guys did this back in Algebra 2. Do you remember what I mean when I say rationalize the denominator? What I'm referring to is that if you have a fraction with a radical on the bottom, you can't leave it there for your final answer. So final answers, all radicals have to move up to the top. So let's look at a problem. If I said 1 over the square root of 3. Okay, if I want to get the square root of 3 off the bottom, do you guys remember what you do? As long as we do the same thing on the numerator and denominator, it's legal. So I could multiply by anything as long as I do it on top to bottom. What I'm going to do is multiply by this exact thing. I'm going to multiply by the square root of 3. If I do that, on the top, 1 times the square root of 3 is the square root of 3. On the bottom, if the numbers are both under the radical, you can multiply them together. 3 times 3 is 9. Now, how does that help me? Yeah, square root of 9 is 3. So we get radical 3 over 3. Okay, all you have to remember, though, is if you do it on the bottom, do it on the top as well. If I said 5 over 4 square root of 2. All I really have to move is the radical. So the 4 itself is not a problem. If you multiply by 4 square root of 2, you'll get the right answer. You're just going to have to reduce more later on. This is all one term because it's multiplied together, so I can just pick and choose. I'm only going to multiply by the square root of 2. So on top, 5 times the square root of 2. 5 square root of 2. On the bottom, 4 times the square root of 2. Or sorry, 4 radical 2 times the square root of 2. If I multiply those together, I get the square root of 4. But the square root of 4 is 2. So the bottom is really 4 times 2, which is 8. Okay, as far as at the end, you need to check and see if you can reduce. You can reduce numbers outside the radicals and the numbers inside the radicals. Okay, since this 2 is under the radical and the 8 is not, I can't reduce those. Let's look at this one. Okay, the difference here is my denominator has 2 terms in it. So it's not as simple as just multiplying by a square root of 3 or a square root of 2. Anybody remember what you did on those? Don't write this down. On the others, we were just multiplying by the radical. If I just multiplied by the same thing here, you have to end up foiling, and I get a square root of 9 minus the square root of 6 minus the square root of 6 plus the square root of 4. Do all of those radicals break down? I can do the square root of 9 and the square root of 4, but the square root of 6's aren't going away, are they? So we had to do something a little bit different. In this scenario, if you have more than one term, you multiply by the conjugate, which is the exact same thing except you switch the sign in the middle. So the original was minus, I'm going to multiply by the plus. If the original were added, you would multiply by a subtraction. So now I have to multiply these radicals. So on the top, when you multiply the radicals together, if they're both underneath, you just multiply your numbers. So we get the square root of 6 plus the square root of 4 over, in the denominator we have to FOIL. So we get square root of 9 plus the square root of 6 minus the square root of 6 minus the square root of 4. Why is that better than what we had a second ago? 6 is canceled. When you multiply by the conjugate, those middle terms are always going to drop. So we have the square root of 6 plus the square root of 4 is 2 over square root of 9 is 3 minus the square root of 4, which is 2. So I get radical 6 plus 2 over 1, or you could just say radical 6 plus 2. I'm going to give you guys one of those to try. While you're working that, I'm going to hand back the take-home quizzes you guys turned in the other day. So you can, we'll talk about those at the end of class, but I'm just going to go ahead and hand them back while I'm walking around to see if you have any questions. So same thing, you've got 2 terms on the bottom, you're going to have to multiply by the conjugate. Okay. So again, even though I only have 1 radical on the bottom, because it's 2 terms, because there's a subtraction, you can't just multiply by the radical 2. We have to do the full conjugate. So I'm multiplying by 5 plus the square root of 2. When we do that, we get 15 plus 3 radical 2 over, on the bottom, 2 terms, so we have to FOIL. 5 times 5 is 25. When you multiply the 5 and the radical 2, the 5 just stays outside. You might even Realize since they're conjugates, they're going to cancel, so if you didn't write that down, that's okay. So I get 15 plus 3 radical 2 over the 5 radical 2's drop. Square root of 4 is 2. So that's 15 plus 3 radical 2 over 23. Questions there? Yes, sir.
I will start off, I just multiply square root of 2 over square root of 2.
Okay. So, can I erase this? Does everybody have it down? So, very good question. Since there's only one square root, why can't you just multiply by radical 2 over radical 2? And if we do that, the top, that's no big deal, we get 3 radical 2. On the bottom, if you're multiplying these, because this is 2 terms, you have to distribute. So you get a 5 radical 2 minus the square root of 4. So it got rid of this radical, but it just moved it over with the 5. Didn't get rid of it entirely. Other questions? Let's look at some more. I'm just going to keep practicing these. How is this one different than the others? It's a cube root. If I just multiplied by the cube root of 3 on top and bottom, you get 4 cube root of 3 over the cube root of 9. Did that get rid of it? No. So we have to do something a little bit different. There are a couple ways we can think about this, but I think I'll walk you through a couple of them. This is a 3 to the first. That means I have 1 3. Because it's a cube root, we need 3 of them before we can pull it out. So if you have 1, how many more do we need? 2. So I'm going to multiply by the cube root of 3 squared. Okay, 3 squared is 9 over, you could write this as 3 to the third on the bottom if you wanted, or 3 times 9 is 27, whatever you prefer. Can you do the cube root of 27? Yeah, that is 3. So you get 4 cube root of 9 over 3. Okay, the other way to think about it is just to think of your perfect cubes. You know, like 2 to the third is 8. 3 to the third is 27. And it's essentially doing the same thing, just writing it a bit differently. You can't do 3 times something to get 8. Can you do 3 times something to get 27? Yeah, that's just 3 times 9. So you could think of it as a 3 squared, or you can think of it as the 9. however it clicks best for you. So let's try this one. When you have these a fraction under a radical, you can split it up. So we could say the 4th root of 3 over the 4th root of 5. Okay, I'm not worried about the top, but on the bottom, I have 1 5 down there. How many do I need? We need 4 total, so we need how many more? 3 more. So I'm going to multiply by the 4th root of 5 to the 3rd. Okay, use your calculator if you need to here. Remember, just pull up that one on your Chromebook. I'm not going to tell you the answer. You guys can open your Chromebook and type it in for me. 3 times 5 to the 3rd. On the bottom, you can write that. You can do 5 times 5 to the 3rd, or if you just want to write it as 5 to the 4th, it doesn't matter to me. What's the bottom simplify to? 4th root of 5 to the 4th is? 5. Let's do this one. If I asked you to simplify this, let's start by breaking down these radicals. Square root of 12. What perfect squares go into 12? 4. So we could think of that as a 4 and a 3. Square root of 4 is 2. So you get 2 over 2 radical 3. Minus, what am I going to break 27 into? So square root of 9 is 3. We get 3 radical 3. Does anything happen here right now that you recognize? They both have a square root of 3. And is there anything else we can simplify? Look at the first fraction. What do you notice about it? We could cancel the 2. Okay. So we have 2 things that we have to do here. We have to subtract these. And we know to add or subtract fractions, you need a common denominator. we also have to get the radical off the bottom. So you can do those things in any order. I would rather subtract them first, so I'm only getting the radical off the bottom one time instead of doing it in each fraction. So if I wanted to make these denominators the same, what would I have to do? Take the first one times 3. So we do that on top and bottom. That gives me 3 over 3 radical 3 minus 1 over 3 radical 3. Since the denominators are the same, we can put them together. Subtract the numerators. 3 minus 1 is just 2. Now, to get the radical off the bottom, what do we have to multiply by? Just the radical 3. So I get 2 radical 3 over 3 square root of 9. Square root of 9 is 3. So on the bottom we have 3 times 3, which is just a 9. And that would be our final answer. Any questions for me there? That's really where I want to stop with this section. So the homework is just to finish the handout that I posted Friday. So it was 23 questions, and I think I told you you could do the first like 16 or 17 of them already. So we have a few to add there. What I am going to do, we've got 20 minutes. I'm going to come around and sit down with you guys individually and go over your quizzes and any other questions that you have for me. So I feel like I hardly get to see you all since we're only seeing you twice a week right now. So I just want to sit down individually and see how we're doing and what questions we have. So go ahead and work on your homework. If you get stuck on one, circle it, and when I get to you, I'll be happy to go over that.